Morning. Today we are continuing with the chapter polynomials. So yesterday we have studied the different what's an algebraic expression, what's the degree of the polynomial, etc. So now we learn about the types of the polynomial. Now we are learning the types. Now this types is based on the degree of the polynomial. Depending on the degree, the polynomials has been classified as different types. So let's take the first type. The first type is called as a linear polynomial. Linear polynomial is the first type. Here the degree is equal to 1. If the degree is 1, we say it's a linear polynomial. For example, so 2x plus 5. Here the variable is x. The power of this variable is 1, therefore degree is 1, and therefore it's a linear polynomial. Now I write 6x. Here again the power of the variable is 1, therefore it's a linear polynomial. In general, the general form of a linear polynomial is written as ax plus b. Ax plus b is the general form of a linear polynomial. So where a and b are the constants and x is a variable. Okay. The second type of the polynomial is the quadratic polynomial. Quadratic polynomial. As the name suggests, the degree is 2. Is equal to 2. If degree is 2, it is called as a quadratic polynomial. Example: x square plus 5x plus 3. The highest power of the variable in this polynomial is 2. Degree is 2. Therefore, it's a quadratic polynomial. Okay. X square. X square is only one term is there, but still the power of the variable is 2. It is of degree 2. Therefore, it's a quadratic polynomial. The general form of a quadratic polynomial is ax square plus bx plus c. Ax square plus bx plus c is the general form of a quadratic polynomial. The third type, when degree is 3, we call it as cubic polynomial. Cubic polynomial. In this, the degree should be 3. Is equal to 3. When degree is 3, it is called as a cubic polynomial. Example: 4x raised to 3 plus 2. Highest power of the variable is 3, therefore it is a cubic polynomial. Or you can have all the terms, that is 2x raised to 3 plus 4x square plus 6x plus 1. This is a cubic polynomial. If there is a single term also, it is a cubic polynomial. Say only x raised to 3. Power is 3, degree is 3, therefore it's a cubic polynomial. The general form of a cubic polynomial is a x raised to 3 plus b x raised to 2 plus cx plus d. The general form of a cubic polynomial is given by ax raised to 3 plus bx square plus cx plus d is the general form of a cubic polynomial. So degree 1 linear, degree 2 quadratic, degree 3 cubic. Okay. So the next type of polynomial is the biquadratic polynomial. Biquadratic polynomial. Here the degree is equal to 4. So when the degree is 4, we call it a biquadratic. Quadratic we have already seen second one, it's a degree 2. 2 quadratics means 2 quadratic means 4th degree. So a biquadratic polynomial is a polynomial of degree 4. Example: x raised to 4 plus 3x raised to 3 plus 2x square plus 7x plus 5. It's a biquadratic polynomial. Degree, highest power of the variable is 4. Degree is 4. It's a biquadratic polynomial. You can have a single term also. 7x raised to 4 plus 5. It's also a biquadratic polynomial. So the general form will again be like this only. A x raised to 4 plus B x raised to 3 plus C x raised to 2 plus dx plus E. This is the general form of a biquadratic polynomial. So we have seen 4 types of polynomials, that is linear polynomial, quadratic polynomial, cubic polynomial and biquadratic polynomial. There are some special cases also. Number 5, it is called as a constant polynomial. Constant polynomial. Constant polynomial means here the degree is 0. Degree is 0, then we say it's a constant polynomial. Now, what's an example? Any number, example is say 15. 15 is a number, it's a pure constant number. So this is called as a constant polynomial. So this 15 can also be written as 15 x raised to 0. The degree of power of the variable is 0, therefore it is called as a constant polynomial. Degree is 0, therefore it's called as a, so every real number is a constant polynomial. Okay, every real number is a constant polynomial means then a question arises, if a number 0 is taken, 0, what about this? What is the power of 0? What is the degree of 0? Here there is some contradiction. So we have one more type which is called as a 0 polynomial. 0 polynomial. 0 polynomial is here number 0 is a 0 polynomial. Okay. So here the degree is not taken into account because 0 does not have a degree. It's only, so because we have said real numbers, 0 is also a real number. Then what type of polynomial is 0? For every number is a real number and every real number is a constant polynomial. Then in that 0, real number, 0 is also a part of it. Then where do I account this for? So this 0 is accounted as a 0 polynomial. So 0 is the only number which is stored as a 0 polynomial. Am I clear? Okay. So now we have seen what are the different types of polynomials. So a small exercise on that. See, identify the constant, linear, quadratic, cubic polynomial from the following. Now if you see this, f of x is equal to 0. That means f of x means it is a polynomial in x. X is a variable going to be used and it's a function of x. Okay. Here the number is 0. It is what type of a thing it is? It's a 0 polynomial. Okay. What it is? It's 0 polynomial. Clear? Poly. I just write polynomial. Now see the second one. Highest power of the variable is 3. Degree is 3. So if the degree is 3, what type of polynomial it is? It is a cubic polynomial. Okay. Now this h of x, polynomial in x, minus 3x plus 1 by 2. Power of the variable is 1, so it is a linear polynomial. Linear polynomial. Here highest power is 2, degree is 2, it is quadratic. Power of the variable is 1, it's linear. Power of the variable is 3, it is cubic. Highest power of the variable is 4, it is biquadratic. Okay, so I think you got an idea how to segregate or identify the polynomials based on the type of the polynomial. Okay, 0 polynomial, cubic, linear, quadratic, linear. Is it clear? So that's the thing. Next. So now next topic is value of a polynomial. Now we have seen the different types of polynomials. So now let's find out the value of the polynomial. Now we will explain with an example. Suppose x square plus 3x plus 2. 3x square plus 3x plus 2 is a polynomial. So we will say it's a polynomial in x. put some value of x, take any value, say I will put x is equal to minus 2. If I put x is equal to minus 2, then I will say it is p of minus 2. That is, wherever x is there, I will replace it with minus 2. So minus 2 whole square plus 3 into minus 2 plus 2. Okay. So minus 2 square is 4 minus 6 plus 2. This is 4 plus 2 is 6 minus 6. You are getting 0. So the value of the polynomial at x is equal to minus 2 is 0. Value of the polynomial at x is equal to minus 2 is 0. Now I suppose I put, now in the same case I put x is equal to 1. When I put x is equal to 1, I calculate p of 1. P of 1, what is the polynomial? X square plus 3x plus 2. I put 1 square plus 3 into 1 plus 2. Okay, 1 square is 1, 3 ones are 3 plus 2 is equal to 1 plus 3, 4, 5, 6. So value of the polynomial at p is equal to 1 is 6. So value of the polynomial is that value for a particular value of the variable x. Then we say this is the value of the value of the polynomial at p is equal to 1. The value of the polynomial at p is equal to minus 2 is 0. So this is the value of the polynomial at a particular value of x. Now here I got a particular value of x as p as 6. Here I got the 0. So if the value of the polynomial is 0, then it is also called the 0 of the polynomial. It is called 0 of the polynomial. Okay, it's correlated. Value of the polynomial, if it is 0, it is also called 0 of the polynomial. So sometimes when they ask you, find the 0 of the polynomial, you are doing nothing but you are finding the value of the polynomial only. If it comes out to be 0, then we say it is the 0 of the polynomial. If it is not 0, we get some value, then value of the polynomial at x is equal to 1 is equal to 6. So that is the difference between a 0 of a polynomial and value of a polynomial. Okay. So 0 of a polynomial and value of a polynomial are further correlated and we get the factors and the remainders. Okay. Now we will see we will take a few examples to find out some more so that you get to know how to calculate the value of a polynomial. Okay, now we take an example to find the value of the polynomial. See, find the value of the following polynomial at the value of x mentioned alongside. That means you have to find the value of this polynomial at x is equal to 3. So for value of the polynomial at x is equal to 3 is, we are going to find p of 3. P of 3 means we are going to write 3 in place of x, wherever x is there. So 3 raised to 3 minus 6, 3 raised to 2 plus 11 into 3 minus 6. So 3 raised to 3 means 3 into 3 into 3. 3 3s are 9, 9 3s are 27. So this is 27. 3 square is 3 3s are 9. 9 6s are 54. Minus sign is a minus 54. 11 3s are 33 plus 33 minus 6. Okay. Now let's add the two positive numbers. 27 plus 3, 30, 30, 60. 60. 54 minus 6 is minus 60. So value of the polynomial at x p is equal to 3 is 0. So p of 3 is 0. Therefore, it is 3 is the 0 of the polynomial. 0 of the polynomial. Because at x is equal to 3, I am getting 0 as the answer. Therefore, p is equal to 3 is the 0 of the polynomial. Am I clear on this? So this was the first one. Let us take another example. Just a minute. Now we take the second example. P of x is x raised to 3 minus 3x square plus 6x minus 10 at x is equal to 5. At x is equal to 5 means I am going to find p of 5. I am going to put 5 in place of x. So it is 5 raised to 3 minus 3 into 5 raised to 2 plus 6 into 5 minus 10. Now 5 cube, 5 into 5 into 5, 5 5 is 25, 25 5 is 120, 125. 5 5 is 25, 25 3 is 75, minus 75. Plus 5 6 is 30, minus 10. Okay. Now you add the two positive numbers. 125 plus 30 is 155. And this is minus 85. So this will be 5 minus 5 is 0. 15 minus 8 is 7. So P of 5 is 70. That means the value of the polynomial at 5 is 70. Therefore, it is not 5 is not the 0 of the polynomial. Okay. So looking at the value, you can conclude whether it is a 0 of the polynomial or not the polynomial. So here we are getting only the value of the polynomial, and since the value of the polynomial is not 0, it is not a 0 of the polynomial, but we get a value of the polynomial. So this is the value of the polynomial at x is equal to 5. If the value of x changes, the value will also change. Clear? Okay. Now we are seeing finding the value of the polynomial. A question based on this value of the polynomial could be asked like this also. Find the value of a of the polynomial this if x is equal to minus 2 is a 0 of the polynomial. So if x is equal to minus 2 is a 0 of the polynomial means if you put x is equal to minus 2 in this polynomial, you should get answer 0. And so here that is why it is told as 0 of the polynomial. So the question could be asked in this way also. So I will just put it. So I am going to put P of minus 2 must be equal to 0 only because it is said as 0 of the polynomial. So now P of minus 2 I am going to put this polynomials here. 4x raised to 4 plus 2x raised to 3 minus 3x raised to 2 plus 8x plus 5a. Now when I start putting value of x as minus 2, so put x is equal to minus 2. So 4 minus 2 raised to 4 plus 2 minus 2 raised to 3 minus 3 minus 2 raised to 2 plus 8 into minus 2 plus 5a, and since it's a 0 of the polynomial, this should be equal to 0. Now 4 times multiplied, 2 2s are 4, 4 2s are 8, 8 2 is 16, and 4 times this thing will be positive number plus 16 plus 2 raised to 3, 2 2s are 4, 4 2s are 8, 3 times, so it will be a negative number, minus 8 you will get, minus 2 square is 4, positive times, so 3 into 4 plus 8 into minus 2 plus 5a is equal to 0. 16 4s are 64. Plus minus is minus. 2 8s are 16. Minus 4 3s are 12. Plus minus is minus. 8 2s are 16. Plus 5a must be equal to 0. Okay. Now these three numbers are negative. So 64, let's add all these three numbers. 16, 16, 32, 33, 34, 44. Minus 44 plus 5a is equal to 0. So 4 minus 4 is 0. 6 minus 4 is 2. Okay. Plus 5a is equal to 0. So let's solve this equation. Take it the other side. 5a is equal to minus 20. A is equal to minus 20 upon 5. If you cut it, you will get minus 4. So a value of a, if it is minus 4, then x is equal to minus 2 will become the 0 of the polynomial. Okay. So the question could ask, same, we are finding actually the value of the polynomial only, but the question is slightly asked in a different way. We are doing nothing but simply like the previous one, we are putting the value of x as minus 2 and simplifying it. And there is some unknown number a, so we need to find the value of that unknown number. That is find the value of a. So here in this particular example, A is minus 4. If A were minus 4 here, you will get 0, therefore it becomes a 0 of the polynomial. That's it, okay? It could also be asked in this way. Make a note of this. So what we have learned so far, we are just giving you a small assignment. So try to solve these sums based on this. So first is verify whether it is a 0 of the polynomial. So this is the value given. See if you are going to get 0 by putting this value. So that you can check whether it is a 0 of the polynomial or not. For here we have got for 3 values. You will have to do it for 1, for 2, for 3. Here you will do it for plus 2, minus 2, plus 3, minus 3. Okay? And check whether you are going to get 0. If you are getting 0, you will write it's a 0 of the polynomial. If you are not getting, it's not a 0 of the polynomial. So that is the value. Similar type of question, find the value of A for the indicated, but it is indicated that this is the 0 of the polynomial. So that means when you put this value in the put the value of x in this polynomial, you should get 0. So with putting that, you should calculate the value of A. Okay? So find the value of A in each of these cases. Okay, we are given the what should be the corresponding x values. Okay, so try this. I will discuss the answers, how to solve them in the next video. Make a note of this.